everybody. This is Notes 46. So Notes 46 is honors only. If you are not in honors, then you can move on. So Notes 46 is compound interest. Compound interest formula is going to help me solve some real world problems. So it says exponential functions are used in situations involving compound interest, right? So we talked about interest previously in our growth and decay formulas, right? If something's getting bigger, something's getting smaller. Compound interest is when the interest that you earn also makes interest. So basically what that means is what happens at the bank. So if you put in $1,000, you work out the interest for the first period. So the first period, maybe that is 1 month. So at the end of the month, the bank gives you a 10% interest. That's $100. Then both of those are in your bank account. And so then the next month, when the bank is going to figure out how much your interest is, they're going to use their total amount. So the $1,100 times the 10% gives you $110. Then both of those things go into your bank account. All right, so you have partly money that you put in, and then partly money that the bank is putting in as interest. And so we see that continue to grow. And so we see that the interest changes from month to month because the amount of money that you have in your bank account is getting bigger and bigger. And so compound interest can be really good if you are making the interest and really bad if someone is charging you the interest. So it gets faster and faster and faster until eventually the line goes up like this and you're making money like nobody's business. This is the reason why somebody like Martha Stewart or Oprah Winfrey is able to live on their interest alone because their interest is making money for them. So we could keep doing this over and over again, right? Where we calculate the 10%, add it together, and then move on. We keep going and going and going, or there's a formula that does it faster. So that formula looks like this. It's a little wonky, but it is A equals P1 plus R over N to the N to the times T power. So what this means is that the future value or the value is the current value. Remember we talked about this being called the initial value. The initial value. And then we have 1 plus R is still the rate. But then we have to divide by N because we're trying to figure out how many times this happens. So this is the number of periods per year. So how many times this growth rate happens per year. So if it's called compounded monthly, then we'd put a 12 where that N is. If it's compounded daily, then we would put 365 days where that is, because that's how many are in a year. That same N goes in the first part of the exponents, and then you put in your time for T. This is how long that is happening for. It looks like kind of a wonky formula, but we will check out how it works here. So an investment account, I'll write it down here just so we have it. A equals P1 plus R over N and to the power of N times T. So it says an investment account pays 4.2% annual interest, so that's per year, compounded monthly, right? So I see that it's happening 12 times per year, right? If $2,500 is invested in this account, what would the balance be after 15 years, right? So I know that the P still is the principal. It's what I started with. I started in this case with $2,500 because that's how much is being invested. I'm going to put 1 plus my rate. Remember, my rate is always a decimal. So I have 4.2, move the decimal place over 2 places. I get 0.042. But this time we're dividing by the number of times that something happens in a year. So this is compounded monthly. That is 12 times. Something like that. And then that same 12 is here. And then it asks me how long, the T. This is 15 years, so it's going to be a ton of years, just like that. Right, so we can do most, if not all of this in our calculator sort of at one time. So I'm going to do the parts that go together. So I would say that this part here goes together, and then this part here goes together. What I mean by goes together is I'm going to write 2500 because that's coming straight down. 1 plus, oops, 1 plus, and then I'm going to go to my calculator, I'm going to type in negative 0.42 divided by 12. So that is there, and it's going to give me 0.0035. Right, and then I also know I can calculate that exponent, 12 times 15 in my calculator, which I know is 180. From there, this is exactly like yesterday. I could type it all in. I can do 2500 times 1.0035 to the power of 180. For sure, sometime soon I want to type in my calculator. So I'm going to do 2500 parentheses 1.0035 to the power of 180 to the power of 180. And the answer that it gives me is 468.86616628. In this case, we're dealing with money, so it makes the most sense to do 2 decimal places for my cents. I see that this one means that we are going to round up. So I'd have $488.87. Put my dollars there. Mark that one up there. Right, so the hardest part is just figuring out what to plug in, and we can put most of it in our calculator. So number 2 says find the account balance after 20 years if $100 is placed in an account that pays 1.2% interest compounded twice a month. All right, so I start with the thing. that I start with. So it started with $100, and I had 1, and it's growing at a rate of 1.2%. Divided by 100 is 0.012. So I have 0.012. It's over how many times per year it goes off. So this is happening twice a month. So 2 times every month, and there are 12 months in the year, so that means 24 months. So I'm going to divide by 24, just like that. And then I need to know how long it's going to go. So that 24 is still there. And then they're asking me how many years it's happening. So it's 20 years. They tell me here. All right, so the 24 matches. We have 100. 1 plus, to my calculator, 0.012 divided by 24. It's going to be a super small 0.0005. And then 24 times 20 should be somewhere around 400. Oh, nope, 576. Right. Just from there. From there, I can type it straight into my calculator. You know what? It should be 20 times 24. I did 24 times 24. So this here is 480. There we go. Better guess. So I'm going to type in 100, 1.0005 to the power of 480, which is 127.11729. Again, it's in dollars, so I have 2 decimal places. That's going to round up. So I have $127.12. That is our final answer. Thanks, guys.